Welcome back to my channel, everyone. Sri Tips here, and today what we're going to do is we're going to restart the silver cell, and we're going to begin by making the electrolyte for the silver cell. This is some silver nitrate from a previous dissolve of pure silver crystal. If you look underneath here, see that the bottom has some pure silver down there, and what we did is we added nitric acid to this and then made some electrolyte with it. So this is going to be about 300 grams of silver nitrate crystals and silver nitrate solution. I'm going to add it to this large beaker. Well, first let me do this. Let me add the I've got about 450 grams of high purity silver. I'm going to add that to our tall beaker here. Now let's add the silver nitrate crystals from a previous reaction. I'm going to add those right into our tall beaker. You can use silver nitrate as a substitute for dissolving pure silver in nitric acid. It's the same thing, actually. Silver nitrate crystals can be used. It's approximately 1.5 to 1, which means it'd take 150 grams of the silver nitrate crystals to equal 100 grams of pure silver in solution. These silver nitrate crystals are highly soluble in water. Look at them beautiful crystals. Pure silver nitrate. Just looks like ice. Very nice. So we're going to go ahead and get this broke up and get it added to our reaction beaker down here. There's about 750 milliliters of, or grams rather, of silver crystal in here. You can see the silver nitrate crystals are dissolving in the water. And what we'll do is I'm going to add some nitric acid to this now. And we're going to start. You should turn on the time-lapse camera back here. Now what I'll do is add some nitric acid to the silver crystals. And what we're going to do is make a highly concentrated silver nitrate solution to act as the electrolyte for our silver cell. I'm going to fill this up. Let's see, we're at 650 right there. I'm going to go to the 1,000 milliliter level with nitric acid. Now that's very strange. I didn't expect that. Some kind of weird precipitate forming in there. What the heck is that? It's almost like I added hydrochloric and not nitric. Very strange. Well, ladies and gentlemen, I've never seen this before. It looks like it's oh, there we go. We're getting through to the silver underneath with the nitric acid addition. I've never seen anything like that before. Of course, I never had highly concentrated silver nitrate crystals forming in here either, so I think it'll be alright. We're just going to stir this up. We've added 450 milliliters of nitric acid. And I think that's going to do it for us. And this will clear up as the reaction progresses. I'm going to cover this up now. I'm going to set this. It's already got some heat to it. I'm going to set this up on the burner here, but I'm not going to turn on any heat yet. I'm just going to let this react normally under the heat that is produced from the reaction. Well, that was definitely bizarre. I've never seen silver nitrate react that way. Hopefully as it heats up. I don't have any heat on it right now. It's still on off. But as it heats up, that solution will clear up for us. And we'll get all that silver to go into solution so we can make our electrolyte. I'm going to give this a little heat now. Just some low heat. It's number 3 on the burner. 3 out of 7 is full blast. I'm putting it on number 3 down here. This is the stainless steel bowl that I use as the cathode. And I just sit here and use a little tool here to scrape all the little bits of silver that are adhering to the bottom of this bowl. And yes, is there a faster way to do this? Probably so. But there's something soothing about going around the bowl like this, a little bit at a time, with this small tool and knocking all these silver crystals down little by little. It satisfies something in me. I don't know what it is, but I enjoy doing this. So if there's anybody out there that says you do it faster, I know there is. I don't care. I like doing it this way. My sweeps. I sweep my melt table up and put the material that I get out of it in here. And then what we'll do is we'll take this, and this gets added to the melt when I do my melting my cement silver into impure granules for the silver cell. We've got all the silver to dissolve in this. This is what silver nitrate looks like. It's clear and colorless like water. This is pure silver crystal dissolved in nitric acid. But you'll notice that there's 0 silver left in the bottom of the beaker. And we always like to have just a little bit of silver left in there. So what I'm going to do is grab a few of these silver crystals. Not much, because if there's a whole bunch, a large amount of excess nitric in here, then this could cause a boilover because this is a real hot solution. So I'm just going to add a few crystals of the silver now, just a little bit, see what happens. Whoa, see there? See there? That's why we do not want to add a whole bunch in all at once. Get a boil over. That was a good demonstration. And I think we still got nitric acid in here, and that's why the silver is reacting like that. So we're going to add a little bit of the silver and then cover this back up and continue to let this react. What I want to see in here when I get done is a little bit of excess metallic silver on the bottom of the beaker. The solution crystal clear and colorless, and no more fumes being produced. The reason we want to consume just about all of the nitric acid out of our silver nitrate electrolyte is because we do not want a large amount of free nitric in our electrolyte. If there is a large amount of free nitric acid in the electrolyte, then what could happen is the impure silver that we're feeding in will contain palladium. Palladium is soluble in nitric acid. And if we have a lot of it in our impure silver shot that we're feeding in the top, then what could happen is that excess nitric in the electrolyte will tend to dissolve that palladium, and then the palladium will travel through the anode filter into the electrolyte and contaminate the electrolyte in the silver cell. Once the palladium is allowed to contaminate the electrolyte, then it could begin to plate out. If it gets high enough concentration in the electrolyte, it could begin to plate out with the silver crystal and contaminate our pure silver crystal. However, contaminated silver is not the issue here. The issue is that the palladium could contaminate the silver, and we'd never even know it by looking at it, because palladium is a white metal. It will appear bright and shiny just like high purity silver. The main problem is that palladium is about 100 times more expensive than silver. We started on this process about 2.5 hours ago, and we're still dealing with it. What I'm going to do is I have some more pure silver here. I'm going to add a little bit of it in. This is a brand new spoon. I don't want to dip a used spoon down into my silver crystal, so this is a brand new spoon. We're going to go ahead and add just a little bit more in here now and see what happens. I got to add it slow because it looks like there's a whole bunch of excess free nitric acid in here. And like I said, I'm trying to get all that acid consumed by adding this silver crystal. There we go. I've been at this now for about 4 hours. I'm going to add a little bit of distilled water to dilute the solution down a little bit. That's about 150 milliliters. And you can see there's just a little bit of fume production still happening in here. But we're very close to getting our electrolyte exactly where we want it. We want zero fume production, And we want a little bit of silver left down on the bottom of the container when we get done with this reaction. And we want a nice clear solution. It's looking pretty good. We're finally there. This has taken about 5 hours, and we've got the solution colorless, no fumes, and we got just a little bit of silver left down in the bottom of the beaker. I'll pull it down now and let this cool off a little bit. This is high purity silver nitrate solution. We could filter this and put it in a tray, allow it to crystallize, and we'd have some very high purity silver nitrate crystals. The silver nitrate solution is still fairly hot. I'm going to dilute it with a little bit of water here. I'm going to stir this up. Now we're going to filter the solution. Just going to pour it right into our filter here and filter the silver nitrate electrolyte. I'm using a shop vac Dacron filter bag. I bought this at Ace Hardware. And what I've done is I've shoved it down into one of these Rubbermaid food cups that has holes drilled in the bottom of it. And then I've cut the lid off and made a retainer ring. And now what we'll do is go around here with a sharp razor blade and cut all of this excess material away. Let's go ahead and reattach the cathode connection. I've scrubbed and cleaned up the cover, and the bowl is pristine and clean. So now we're going to reattach the cathode connection. I'm going to put the cover on the cell now. Stick it on top like that, and then we'll put some paper up here to keep anything from falling down in there. Now we're going to make the cathode connection here. This is connected to the negative side of our power supply. Here's our filtered electrolyte. Silver nitrate in solution is crystal clear and colorless like water. There's probably close to a liter, and not a liter, a kilo of pure silver dissolved in this liquid. We're going to go a little heavier than we normally do with the concentration, and we're going to do this as an experiment to see if this will grow the large crystals for us. Now we'll dilute the solution with some distilled water. Stir the solution to make sure we got a consistent mix in here. Now we're going to set the lid on here, the cover. I'm going to charge up the anode filter with impure silver. Insert the anode filter basket with the impure silver in it down into the electrolyte, and the bottom of this anode basket will be suspended in contact with the electrolyte in the cell. I've made up my connections. I've got the anode electrode bar down here connected to the positive side of the power supply, and we're going to put that on top of the impure silver. And let's look down in here and see what we got. That's what it looks like down inside the cell right now. You can see the anode basket is suspended in the electrolyte. And now what we'll do, come up here, hit the power button, and energize power to the cell. Zero amps. Sometimes that happens, and we got to wait for the electrolyte to soak into the basket and make contact with the anode down in the electrolyte. Now we've got some current flow. Leave the voltage set at 3.5 volts and let the current go where it may. The current's going to wander around based on the conditions that exist in the cell. There's the power supply up above, and I've got the connections coming down and making contact with the cell. What happens is the electrical flow goes through this anode electrode bar, makes contact with the impure silver in the anode filter basket. It dissolves the silver, and then the dissolved silver travels through the anode filter, through the electrolyte, and then the silver plates out on the inside of this stainless bowl as high purity silver. The current flow continues up through here, through the cathode connection, back to the negative side of the power supply. The silver cell is up and running. That is how we do that. When we get done, after about 10 days, Most of this impure silver will be fed into the anode filter basket, and then as it dissolves, it drops down, and we replenish it with the impure silver. A few months ago I had about 25 pounds, and this is all I've got left of that. So we're going to have to break out the furnace and melt up some more impure silver shot for the silver cell. After 10 days, this is 3 runs of the silver cell, about 4,500 grams of pure silver crystal. And that's what we'll get out of the silver cell in about 10 days. Should get about 1.5 kilos of high purity silver, just like this. And then last but not least, this is the cement silver that we cemented out in my last video. That's what that looks like in there. There's a piece of copper pipe and the silver cell electrolyte contains silver nitrate, and we put that copper in there and we cemented out the silver out of the electrolyte. Alrighty, this will conclude the video. Thank you for watching.